Hello and welcome to Intertech Global Training. I'm Kern Wildhaber, and today we'll be discussing the new control board in the YT, VT, and VS models. Many technicians find it helpful to have the installation and operation, or IOM manual, available during this video. Let's get started. The microprocessor-based printed circuit board controls the inputs to the unit as well as outputs for status, mode, faults, and diagnostics. A status LED and LEDs for each fault are provided for diagnostics. A removable low-voltage terminal strip provides the necessary terminals for thermostat connections. Some models offer an additional removable terminal strip for accessory wiring connections. The YT and VT water-to-air models offer an ECM control board option providing field-selectable airflow and dehumidification mode, plus an LED to indicate CFM, 100 CFM per flash. Next, we'll discuss the built-in features of the boards. The unit will not operate until all the inputs and safety controls are checked for normal conditions. The controls are checked quickly in the blink of an eye when there is a call for heat or cool. A 10 to 20 second random start delay is added at power up and whenever a Y1 call is received at the unit. This avoids multiple units from being energized at the same time after power loss or other situations. Standard in the control is a built-in 5-minute anti-short cycle timer. The delay provides short cycle protection of the compressor. Built into the board are timers. Components are sequenced and delayed for optimum space conditioning performance and to make any startup noise less noticeable. For example, there is a short delay between the blower motor and the compressor startup. The microprocessor control allows the technician to shorten timing delays for faster diagnostics by removing the test jumper located on the lockout board. It should be reinstalled for normal operation after testing. The status LED will not be illuminated during the test mode. When provided, the YT and YU terminals on the accessory terminal strip provide a field connection for a valve with an in switch, which is recommended. The YT terminal can be used to power the solenoid valve and in switch. The YU terminal can be powered through the in switch and connects internally to the Y circuit of the unit controls. An accessory relay terminal A can be used for solenoid valves without an in switch. This terminal is energized 10 seconds before the compressor contactor. A valve without an in switch could cause a water hammer issue and is not recommended. In models without an accessory terminal strip provided, connect the valve with an in switch in between Y1 of thermostat and Y1 at the thermostat terminal strip. Also, a valve without an in switch can be connected via the spade terminal labeled A on the lockout board. Connections for a humidistat are provided for some models such as the YT utilizes this board. When connected, the fan will be automatically engaged when the humidistat contact closes. A field connection is provided at the terminal strip for external control of the on-demand dehumidification (ODD) feature for the variable speed ECM fan motor, which automatically lowers the fan speed when the space humidity is higher than the set point. Either connection may be used with the thermostat that includes humidifier, dehumidification outputs. In ECM-equipped models without an accessory terminal strip provided, connect ODD and G on the ECM board directly, packaged units only. For units equipped with PSC blower motors, connect the thermostat's humidifier terminal to G on the unit's thermostat terminal strip. On units equipped with an ECM blower, an LED on the ECM fan control board flashes one time per 100 CFM when the unit's fan is operating to indicate airflow. The resistance heat control module contains the appropriate high voltage control relays. Low voltage control signals from the lockout board energize the relays in the resistance heat module to engage backup resistance heat when necessary. The lockout board offers a pass-through W1 signal, first stage resistance heat, and a relay output with a time delay for the W2 signal, second stage resistance heat. If Y1 and Y2 are not present and W1 is present, the board recognizes this as an emergency heat call. If the Y1 and Y2 are present with the W1, it recognizes the call as an auxiliary heat call. When the Y1 and Y2 are not present, the time delay for the W2 relay is 2 minutes. When the Y1 and Y2 are present, the time delay for W2 is 10 minutes. The lockout board receives separate signals for high pressure, low pressure, load heat exchanger freeze, source heat exchanger freeze, condensate overflow, and hot gas temperature limit faults. After a continuous 30-second measurement of any fault, except the high pressure fault, the compressor operation is suspended. The high pressure fault is immediate. The appropriate LEDs flash for each fault. Once the unit is locked out, an output of 24 volts AC is energized on the L terminal for remote indication of a fault at the thermostat. Here's a little more detail on the faults. If the low pressure switch is open continuously for 30 seconds, the compressor operation will be interrupted and the control will go into fault retry mode. At startup, the low pressure switch is not monitored for 30 seconds to avoid nuisance faults. Note, if the low pressure switch is open before startup, then the unit will not start upon receiving any Y1 call and will lock out instead. If the high pressure switch opens, the compressor operation will be interrupted and the control will go into fault retry mode. There is no delay between the time the switch opens and the board entering into fault retry mode. There is also no delay of switch monitoring at startup. Note, if the high pressure switch is open before startup, then the unit will not start upon receiving any Y1 call and will lock out instead. When in cooling mode, if the load heat exchanger temperature is lower than 30 degrees for 30 continuous seconds, the compressor operation will be interrupted and the control will go into fault retry mode. The sensor is located on the refrigerant line in between the heat exchanger and TXV, the refrigerant inlet of the heat exchanger in cooling mode. When in heating mode, if the source heat exchanger is lower than the set point for 30 continuous seconds, the compressor operation will be interrupted and the control will go into fault retry mode. This is important. The set point is 15 degrees for closed loop with the A-FRZ or A-freeze jumper removed and 30 degrees with the A-FRZ jumper installed for open loop. At startup, the sensor is not monitored for 30 seconds to avoid nuisance faults. This sensor is located on the refrigerant line in between the source heat exchanger and TXV, refrigerant inlet of heat exchanger in heating mode. Note, the unit is shipped with the jumper installed. It is important to remove the jumper for closed loop applications. The control board utilizes an impedance sensing liquid sensor at the top of the drain pan. When water touches the sensor for 30 continuous seconds, the sensor sends a ground signal to the lockout board indicating a condensate overflow fault has occurred. If water touches the condensate overflow sensor for 30 continuous seconds, the compressor operation will be interrupted. The control will go into a fault retry mode. There is no delay of switch monitoring at startup. When T2 is greater than 220 degrees for 30 continuous seconds, compressor operation will be interrupted. The control will go into fault retry mode. The fault retry feature is designed to prevent nuisance service calls. All faults except over/under voltage are retried twice before finally locking the unit out. There is an anti-short cycle period of 5 minutes between fault retries. On the third fault within 30 minutes, the board will go into lockout mode and the call for service indicator on the thermostat will illuminate. If the thermostat is powered off for 1 minute, then back on, it performs a soft reset and the board will reset. The last fault will be stored in memory for ease of troubleshooting. If power is interrupted to the board, the fault memory will be cleared. The lockout board protects the compressor from operating when an over/under voltage condition exists. If primary voltage is high, so will be secondary voltage. The control monitors secondary voltage, 24 volts AC, to determine an over/under voltage condition is occurring on the primary side of the transformer. For example, if the secondary voltage is 18 volts AC, the primary voltage for a 240 volt unit would be approximately 180 volts, which is below the minimum voltage of 197, recommended by the compressor manufacturer. An under voltage less than 18 volts AC causes the compressor to disengage and restart when the voltage returns to greater than 20 volts AC. Over voltage greater than 31 volts AC causes the compressor to disengage and restart when the voltage returns to less than 29 volts AC. When an over/under voltage condition occurs, the board will initiate a fault, shut down the compressor, and start the 5-minute anti-short cycle, or ASC period. During lockout, all 4 fault LEDs will flash, HP, LP, FS, and CO, and the thermostat call for service indicator will be illuminated. This feature is self-resetting and never retries or locks out. If voltage returns to normal range, normal operation will resume if or when the ACS period is over. When normal operation is restored, the 4 fault LEDs will stop flashing and the call for service indicator will turn off. While in lockout mode, If the thermostat is calling for auxiliary heat on W1, emergency heat mode will energize. W2 is energized 2 minutes after W1 is energized. The lockout board includes 5 LEDs. They are green for high pressure, orange for low pressure, red for freeze stat, yellow for condensate overflow, and green for fast and simple control board diagnosis. Along with this video, you'll want to download the workbook including this table on Intertech Global's website.
The controls check for HWG temperature at T3 in the hot gas compressor discharge line, or HGT temperature at T2. The hot water generator pump is de-energized when the leaving water temperature on T3 is above 130 degrees Fahrenheit, or when the compressor discharge line on T2 is cooler than leaving water temperature on T3. Also, when the hot gas line temperature on T2 is higher than 220 degrees Fahrenheit, the HWG pump will be de-energized. All these issues will break the circuit of the HWG pump via the HWG signal from the lockout board, but will not lock out the compressor except when T2 is greater than 220 degrees Fahrenheit. Units without a HWG also do not have sensors T2 and T3. The control ignores T2 and T3 and disables faults 15 and 16, sensor bad. The lockout board includes 4 jumpers for field selection of various board features. When the FS jumper is installed with the T1 and T4 monitored and FS terminals are ignored, the board operates in the load and source heat exchanger temperature sensing mode, which is the factory setting. When the FS jumper is removed, a flow switch can be used on the FS terminals.
When the A-freeze jumper is installed, the board operates in the open loop mode. The set point for the source heat exchanger freeze sensor is 30 degrees. When the A-freeze jumper is removed, the board operates in the closed loop mode. The set point for the source heat exchanger freeze sensor is 15 degrees. Be sure and remove the jumper for closed loop systems to avoid premature lockouts. When the test jumper is installed, the board operates in the normal mode. When the jumper is removed, the board operates in test mode, which speeds up all delays for easier troubleshooting. While in the test mode, the T1 and T4 sensors will be checked for proper location based on temperature. Sensors are swapped if T1 is greater than T4 in cooling, or T1 is less than T4 in heating. This fault will only show up in the test mode. When service is complete, the jumper must be reinstalled in order to make sure the unit operates with normal sequencing delays. While the test jumper is removed, the status light, bottom green, will remain off. If the test jumper is not reinstalled, the control will revert to normal mode after 1 hour, green status light blinking. When the over-under jumper is installed, or the O/V jumper, the over-under voltage feature is active. When the jumper is removed, the over-under voltage feature is disabled. On rare occasions, variations in voltage will be outside the range of the over-under voltage feature, which may require removal of the jumper. However, removal of the jumper could cause the unit to run under adverse conditions, and therefore should not be removed without contacting technical services. An over-under voltage condition could cause premature component failure or damage to the unit controls. Any condition causing this fault must be thoroughly investigated before taking any action regarding the jumper removal. Likely causes of an over-under voltage condition include power company transformer selection, insufficient entrance wire sizing, defective breaker panel, incorrect 24-volt AC transformer tap inside the unit control box, or other power-related issues. When equipped with an ECM fan motor, the ECM fan control board includes 2 types of dehumidification mode: constant dehumidification mode and on-demand dehumidification, ODD. If the ECM control board is set to constant dehumidification mode, the ECM fan runs at normal airflow in all heating stages, but all cooling operation will be 85% of the current stage airflow level based on the dip switch settings. The dehumidification mode lowers the airflow through the evaporator coil to improve latent or dehumidification capacity. In ODD mode, a humidistat or a thermostat with a dehumidification output, with the output being reverse logic, it must operate like a humidistat, connecting to the ODD terminal. When the module receives a call for dehumidification, 0 volts on ODD, the fan runs at 85% of the current stage airflow in the cooling mode. Otherwise, the airflow is at the normal airflow level. The signal is ignored in the heating mode. When an ECM control module receives a G call without a call for heating or cooling, the fan operates at 50% of the full load airflow CFM level based on dip switch settings. VS units with the PSC fan start at 100% airflow level immediately after the GE input. In the IOM on page 22, you'll find a partial table for sensors, valid range, and temperature versus resistance characteristics. To test a sensor, you'll want this page in front of you. Included with the video is a more comprehensive resistance temperature chart. More temperatures and values make it easier to troubleshoot. To test a sensor, you must immerse the sensor into a known temperature. For example, immerse the sensor in a 32-degree ice bath or a known air temperature. You must use very pointed test leads, one for tiny surfaces, and measure it on outside of the sensor connector. Important, do not insert leads inside the pen. You may ruin the connector. Fine tips are available for most meters as an accessory. Sensors are semiconductor sensors. If they go bad, it would be either open or shorted. As a general statement, sensors rarely fail. Make sure the sensor is in good contact with the tubing before you condemn it as bad. For example, the sensors have a resistance such as 30 degrees Fahrenheit, the resistance would be 28.61 kiloohms, and 77 degrees Fahrenheit, the resistance would be 10 kiloohms. We hope you found this video helpful, and remember, download the IOM and the expanded temperature resistance charts to help you in troubleshooting the controls and sensors. If you have further questions, please call technical support, and thank you for watching Intertech Global Training.